Okay, so for our next set of notes, we are now going to be using that GCF idea to factor by grouping. So we have factored before, but this is factoring by grouping. So when we factored before, we could only factor when we had 3 terms. So today we're going to talk about what to do when we have 4 separate terms that we are trying to factor. And we're going to use a method called grouping. So when we are factoring by grouping, you will always put the first 2 terms inside of a set of parentheses, and then you will always put your second 2 terms inside of a set of parentheses. So those are our 2 groups. First 2 things always go in a group, and the last 2 things always go in a group. So what we do first is we're going to completely ignore that second set of parentheses for now. So looking inside of that first set of parentheses, we're looking for a GCF amongst those 2 terms. So what is a number that will go into 8 and 64, the biggest possible number? Well, we know that 8 would go into 8 and negative 64. So we're going to use an 8, but both of these terms also have r's in them. The first one has an r cubed, and the next one has an r squared. So the biggest that we can pull out is an r squared. So I'm going to pull out an 8r squared. So I'm going to write that down just below it. So I pull out an 8r squared. And remember, we're ignoring that second set of parentheses over here. So if we were to take out an 8r squared, let's see what we would have left. So we're going to write it just like we did on our other homework assignment. Our GCF goes out in front. We write what's left when we take it out in the parentheses. So 8 divided by 8 is just 1. And if I take r squared out of r cubed, all that's left is r. All right, and then we have negative 64 divided by 8. Well, negative 64 divided by 8 is going to leave us with negative 8. Excuse me. And if we take an r squared out of r squared, there's no more r's left. So this is what we have. All right, now we're going to cover up the first set of parentheses, and we're going to do the same thing here. So I'm looking for something that these 2 might have in common. Are there any numbers that I can pull out of r and negative 8? No, because r doesn't even have a number, right? And then I think about variables. Well, this one has an r, but this one doesn't. So there is no GCF here. So I just have a plus r minus 8. All right, so here's my first piece, and here's my second piece. Do we notice that these 2 have something in common? They both have an r minus 8. So just like a GCF, we're going to take that out of both pieces. So they have this part in common. So I'm going to take it out and pull it to the front. Okay, so basically now that I've pulled that to the front, this part's gone. Then you write your leftovers in a second set of parentheses. So my leftover from here is 8r squared. And since I took this away, r minus 8 divided by r minus 8, that's not 0, right? When you divide something by itself, you get 1, like 3 divided by 3 being 1. So I still have a positive, because there's a plus sign there, I still have a positive 1. So once you have pulled the GCF out of both pieces, you see if you have anything in common. If you do, pull it to the front, and we put our leftovers in our second parenthesis. Let's try that again. So the first thing we do is put our groups together. So the first 2 things go together, and the last 2 things go together. So I'm going to cover up my second set for now. So I'm looking for something that I can pull out of both of those. So the biggest number that I can pull out of 12 and 21. The biggest number I can probably think of is 3. But these also have variables in common, right? They both have a p cubed and a p squared. So that means the most I can pull out is a p squared. So I'm going to pull out 3p squared. And let's see what we would have left if we took that out. So if I pull out a 3 from the 12, 12 divided by 3 is 4. And if I take a p squared out of p cubed, I'm only going to have 1p left. All right, then negative 21 divided by 3, it's going to give us negative 7. And p squared divided by p squared, they go away. All right. Then I cover up my first set of parentheses, and I'm looking at that second set. Is there any number that I can take out of both 28 and 49? So both of those numbers are divisible by 7. So I'm going to pull out a positive 7. Okay, when I do that, let's see what we might have left. So covering this up for now, 28 divided by 7 is going to give us 4, and it has a p with it, so we got the p. And then negative 49 divided by 7, a negative divided by a positive is a negative. You have negative 7. So in my two pieces, so I've got one piece here and one piece here, we look for something they have in common. They both have a 4p minus 7. So I'm going to pull it to the front. And then I'm going to make another set of parentheses for my leftovers. So if I take that out, my leftovers in the first set are 3p squared. My leftovers in the second part are plus 7. And there we go. There's our answer. All right. Number 3. So we group our first two things together and our last two things together. So in that first set, the biggest number that will go into both 12 and 2 would be 2. And I can pull an x squared out of both of them. So if I divide 12 by 2, I'm going to have 6. If I take x squared out of x cubed, we're just going to be left with 1x. And 2x squared divided by 2x squared is just going to leave us with 1. Anything divided by itself is 1. All right, in the second set, trying to think of something that will go into negative 30 and negative 5. Well, I can pull a negative 5 out of both of those. So I pull out a, oops, sorry, I forgot to put that before my parenthesis. I can pull out a negative 5, and then we're going to write what we would have left. Well, negative 30 divided by negative 5, a negative divided by a negative is a positive. We're going to have a positive 6x. And negative 5 divided by negative 5, remember, when I pull out a negative here, a negative divided by a negative is going to leave us with a positive 1. All right, so now I notice they both have a 6x plus 1 in common. So I'm going to pull that to the front. And then I need to write down my leftovers. So my leftovers from the first piece would be 2x squared. My leftovers from the second piece is negative 5. And there we go. All right, let's do it again. So on number 4, we got to make our groups. All right, and then we need to pull some kind of a GCF out of our first group. So in that first group, what number would go into 6 and 16? 6 won't go into 16, but they are both even. 2 will go into both of them. And they both have at least a v squared, so I can pull out v squared. So if I divide 6 by 2, I'm going to have 3. And I took v squared out of v cubed, so I have 1v left. Then I have negative 16 divided by 2, which is going to give us negative 8. And I took out v squared, so no more v's. All right, next set, 21v minus 56. So I'm looking for a number that both 21 and 56 are divisible by. Well, my factors that I might be thinking of for 21 would be 7 and 3. So 7 bigger. 7 will go into 21, and it will also go into 56. So we're going to pull out a positive 7. All right. So 21 divided by 7 is 3, and it has a v with it. And negative 56 divided by 7 is negative 8. So our two pieces do have something in common. So I'm going to pull it out here to the front. So that goes away. And then I need to write down my leftovers. 2v squared plus 7. So if we were to write down our steps, first step is to make groups. Okay, second step is to take GCF of both groups. Okay, taking the GCF out gets us this first line here. Step 3, pull GCF to front. And step 4 is to write leftovers in a second set of parentheses. All right, so let's try a couple more. Okay, number 5. So if we look back up there, our first step was to make our groups. So in group 1, I'm looking for a GCF, a number that goes into 63 and 54. So that would be 9. And they both have at least an n squared, so we can take out an n squared. All right, so if I divided 63 by 9, I'm going to be left with 7, and I took an n squared out of n cubed, so there's still one n. And 54 divided by 9 is 6, and we took out the n squared. All right, now in our second group, looking for the biggest number that goes into negative 105 and negative 90. Well, we know they're both divisible by 5, right? Because we got 5 and 0. But we're probably looking for something bigger than that. 10 won't go into both because this does not end in a 0. So our next best option is 15. So I'm going to pull a negative 15 out of both. So 105 divided by negative 15 is 7. It has an n with it. And then negative 90 divided by 15 is positive 6. All right, so we have now pulled the GCF out of both. So now we're going to pull the common factor between these two out, which is the 7n plus 6. And then our next step is to put our leftovers in a second set of parentheses. So my leftovers from the first part are n squared minus 15 from the second part. Okay. So all the other times in our section here, we've had numbers like 2 and 5 or 2 and 7. that don't have anything in common. But 9 and 15 are both divisible by 3. So I'm going to keep my 7 in plus 6, but now I'm going to pull a 3 out of this set. 9 divided by 3 is 3 with the n squared, and negative 15 divided by 3 is negative 5. All right, so this last step only happens if these two numbers are divisible by something in common. All right, so for example, if we were to look back up here, 8 and 1, they don't have anything in common. 3 and 7 don't have anything in common. 2 and 5, nothing in common. 2 and 7, nothing in common. So this is the first one we've come across with a 9 and a 15 that were both divisible by a number. All right. So once you get to this answer, just check those two. See if we can simplify it any further. All right, number 6. We make our two groups. In group 1, I'm looking for the biggest number I can pull out of 21 and 84, and that would be 21. And they both have at least k squared. 21 divided by 21 is 1. If I take k squared out of k cubed, I'm left with k. Negative 84 divided by 21 is going to give you negative 4, and we took out the k squared. All right, now I'm looking for a number I can pull out of 15 and negative 60. I can pull out a positive 15. If I take 15 out of 15, all I'm going to be left with is k. And if I take 15 out of negative 60, we're left with negative 4. So now they have that in common, so I pull it to the front. And then I put in my leftovers, 21k squared plus 15. All right, so looking at this one, is there a number that will go into 21 and 15? The answer is yes. We can pull out a 3 from both of those numbers. So I keep my k minus 4, but in this parenthesis, I can pull out a 3. So I'm going to pull out a 3. 21 divided by 3 is 7. We have the k squared, and 15 divided by 3 is 5. All right. So again, our steps are to make your groups, take a GCF out of both groups, then you pull the GCF to the front or whatever they have in common. So maybe I can say pull common, so we're not using the same word. Pull what they have in common to the front, and then write your leftovers in a second set of parentheses. And then actually our last two had a step 5, which is to simplify second parenthesis if possible. So that won't be something we can do every time. Like we couldn't do it on the first 4, but we were able to do it on these last 2. We were able to pull a number out of both terms in the second set. All right, that is it.